This is Chapter 2, Section 2 homework. Title is Polynomial Functions of a Higher Degree. So we've been dealing with second order polynomials up to this point, so higher would be third order or higher. And we're going to start in on problem 13. So the first couple are matching curves, but we're going to first determine the right and left hand behaviors of the graphs of the polynomial functions. So let's just look at the three kinds that we most likely to see: second order, third order, and fourth order. And they might have a little more complicated things going on in the center for these third order and second order. This is of the basic form y equals x squared. This is y equals x cubed. This is y equals x to the fourth. And you'll notice that if the exponent is even, then we have the same end behavior. If it's positive x squared, it goes up, and if it's negative x squared, then it goes down. For cubic behavior, it depends upon the sign in front of the cubic part of the expression. We can have all these other terms. So positive goes this way, and negative is going to go that way. So we know the end behavior is that this goes to positive infinity, this goes to negative infinity, and the black curve is the opposite. So the red curve would be y equals negative x cubed. And the same thing applies for the fourth power. If it's positive, the fourth power, then it goes up at the ends. And if it would be negative x to the fourth, then it would go down to negative. Both sides would go to negative infinity. And you can generalize that to any odd or even power. So that's what we're asking. That's what they're asking in this particular case. So we just need to look at the highest order term and look at the sign. So 13 is f of x equals 1/3 x cubed plus 5x. So the only thing we have to look at that term, and we have to see what the sign is, which is positive because it doesn't say anything else. So what we can say is that the left-hand behavior is going to go down to negative infinity as far as the y value, and the right-hand side is going to go up to positive infinity. Now what goes on in between we don't really know, and we're not really concerned with that at this particular point. Okay, so 15 is a second order expression. And again, we just concentrate on the highest order term, which is this one. And we look at whether the exponent is odd or even. So that's even. And we look at the sign. So as far as end behavior is concerned, again, we can draw our axis. And what's going to happen is that because of the negative sign, they're both going to go down to negative infinity when x goes to positive or negative infinity. So the left-hand behavior is down to negative infinity, and the same with the right hand. Now, if this had been plus 3x squared, then it would have gone the other way. Okay, 25. We've got a couple problems in here. Find all the real zeros of the polynomial function. Determine the multiplicity of each zero. So we haven't talked about polynomial division yet, so we're not going to use that, or synthetic division. So we have to use some other means of factoring these. Basically, we've got to factor these equations somehow or another. And I see that that's actually 25 is in the previous section. So it says, use a graphing utility to graph the functions in the same viewing window. Zoom out sufficiently far to show that the right-hand and left-hand behaviors of the function appear to be identical. So in the case of f of x, we've got negative the quantity x to the fourth minus 4x cubed plus 16x, and the second function is just negative x to the fourth. So the second function is basically the first function, except we dropped the two terms here. And when x gets very large, these two curves approach each other. And they have the same end behavior, meaning they're going to be pointing downwards, like this one over here. So what I'm going to do is I'm going to go to my graphing program. I'm going to enter both of those functions. So I've got negative quantity x to the fourth minus 4x cubed plus 16x. And the second one is just negative x to the fourth. And when I graph it initially, they're going to look quite different. But what I do is I zoom out and so it takes a while to zoom out, but you can see, let's do it so what you can see is that at this zoom, that the blue curve, as you go to negative infinity with x, you're approaching negative infinity with y. The same with the red curve. The blue curve, which is the y equals negative x to the fourth, is symmetric around the x-axis. The one is asymmetric. But as far as the behavior and behavior on the left and the right-hand side, they're both going down in both cases. So that's what they're looking for. That's the question. Okay, now we move to the next group, 35. So here we're looking for the real zeros. So we have ft is equal to t cubed, it is t cubed, minus 4t squared plus 4t. So first thing you do when you're factoring expressions is you look to see whether x or t or whatever the variable is in each term. You see we don't have a constant term, so what that allows us to do is to factor out the t. So when you get that, t cubed becomes t squared becomes t just becomes 1, and so that's the first step. Factor out the t, and then I have a quadratic expression, which I should be able to just factor by observation. So I'm going to have t as the first term. Two numbers multiplied together equal positive 4, but when added together give negative 4. Well, the answer, and that works because the coefficient in front of t squared is 1. So if you make them both negative 2, that's going to work. So this times that will give you t squared, you get negative 2t again, gives you negative 4t, and negative 2 times negative 2 is positive 4. So those are my three zeros, and you can, so I have zeros, and these are all real zeros. I have zeros at x equals, or t in this case, t equals 0. That's from this term. And then I have 2 zeros at t equals 2. So t minus 2 has to equal 0. So if you solve for t, you get t equals 2. You'll see if I plug that back in, I get 2 minus 2, which is 0. And I have a multiplicity of roots because I have this root twice. And usually what that means is if you have a double root like that, the function will come down and just touch the x-axis from either direction. So it doesn't actually intersect it, it just touches it. So that's when you have multiplicity of roots. Okay, next problem is 37. So a similar problem. So we have g of t is t to the fifth minus 6t cubed plus 9t. Again, just like the previous problem, we're going to factor out a t. So we get t, and then we'll have t to the fourth minus 6t squared plus 9. Now, this looks like a fourth order. It is a fourth order polynomial, but we might be able to use, I'm not sure what the exact wording is, but you know, we instead of having t minus something, t plus something, we have t squared. And that, so what I'm saying is you'd have t squared plus or minus some number and t squared plus or minus some number. So when I take FOIL first, I get t to the fourth. And that works out because this is 4, this is 2, and that's essentially t to the 0 power. So that gives me this possibility, and then I see, can I factor this? Two numbers multiplied together give me 9, but added together give me -6. Well, it's just like the previous problem, except it's -3 in 2 places. And then you can factor each one of these, or you could actually, probably the easiest thing to do would be to set them equal to 0, and they're the same, so we'll get the same answer either way. So you get t squared is equal to 3, same here. Take the square root, so you get t is plus or minus the square root of 3. You get t is equal to plus or minus the square root of 3. So again, I have 3 zeros. I have when t equals 0, when t equals negative the square root of 3, and I have t equals positive the square root of 3. But I have 2 of them, so I have 2 roots at this value and 2 roots at this value. And so these values, we should touch the x-axis, but we won't actually intersect it. It only intersects at this one. So let's actually plot this thing out. And let's go back to our standard zoom. So if we have x to the fifth minus 6x cubed plus 9x. I got something wrong there. I got a t. What should I put in? 6. Okay. X to the fifth minus 6x cubed. Okay, that looks good. I do graphs, and so you can see we have the intersection of x equals 0. We have the touching at plus or minus the square root of 3. Okay, 52. So there it says find a polynomial function that has the given zeros. So the easiest way to do that is, like 52 has 3 zeros. So we'll say f of x. And you just make up 3 factors like that. And since, again, you could have multiple ways of doing this, the easiest way is just to use x as the first term. And the 3 numbers, you have 0, so I'm going to have minus 0. You'll have negative, you have positive 2, so this will be negative 2, and positive 5, so this will be negative 5. So you can see when x equals 0, this is 0, so the whole thing's 0. When x is equal to 2, this goes to 0, and when x equals 5, that goes to 0. So they're probably looking for you to multiply it out. So I'm going to just replace x minus 0 with x, and then use FOIL. Here we'll get x squared minus 7x plus 10. And then we'll finally multiply x times all those terms, so you get x cubed minus 7x squared plus 10x. And that is a function that will give you those 3 zeros. 58. There it says find a polynomial of degree n that has the given zeros. So let's see, this is 58. So the zeros are x equals -8 and -4, n equals 2, which means it's going to be a squared function. So it's the same thing we did before. Squared function means you have two factors. Two factors. They don't have to be, well, they have to be real in this case because they give you the x number. So again, you take the opposite sign. So if you have an x of -8, it's x plus 8 is the factor. And the same with here, you have x plus 4. So when x equals -8, this term goes to 0, so the product is 0. And then this is -4. This goes to 0, which is 0 times, in this case, 4 gives you 0. And again, you can multiply it out to get x squared plus 12x plus 32. So that's a second order polynomial, and it has x-intercepts or zeros as such. Okay, there's another 64 is another one of those. So we got x equals -4, -1, 3, 6. It's a fourth order polynomial. So we got 4 zeros in the fourth order, so that makes a piece of cake. So it's f of x, and we draw, 4 factors here. So you got x, 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 and you take the opposite sign. So that fourth order polynomial will have the zeros, and that's kind of long, so I don't know if I'm going to multiply it all out. Okay, 65. So you got zeros of x equals 0 and x equals -4, and it's a fifth order polynomial. So this is an interesting one. So typically you have, when you have an odd degree, you have an odd number of zeros. But we only have 2, so that must mean one of these we have to make a double 0. So it could either be 0 could be the double 0, or -4. So I'll show you both ways. So you could have x minus 0 times x minus 0 times x plus 4. Or I could do x plus 4 times x plus 4 times x minus 0. Has to be one of those two because I need 3 real zeros. I can have more than one 0, but I have to have that. And then you multiply by something that is not factorable so that you can't get any zeros. So usually if you take x squared and you do something like x plus 10. If this term is positive, then, and this one is positive, and especially if this number 10 is much larger than the coefficient in front of x, the x term, then you're not going to get any real roots. You can think about what that's doing is, this, if you complete the square on this thing, so you put it in a standard form, you take half, well, let's put 2x in there because that'll make it easier to calculate this whole thing. So let's put 2x. So you'd have x squared plus 2x. You take half of 2, which is 1, and you square it, so that would be equal to 1. So you add 1 here, and you subtract 1 there. And so that becomes x plus 1 squared plus 9. Well, when you complete the square, and if that term is still positive, that constant term is still positive after completing the square, then it's not going to intersect the x-axis. So here you have a x shift of 1 unit. The vertex is at 1, 9, and it goes up. So there's no way that it can cross the x-axis. And you could have the same thing if you had a negative. You could have it go like down this way if you wanted to. So there's an infinite number of possibilities. You just have to choose this so that there are no intersections of that quadratic term. And so when you multiply everything out, you'll have x times x times x times x squared, which is x to the 5th. It becomes a 5th order polynomial.